Alright, in this video we're going to be talking about access modifiers. And access modifiers are a way to give a type or a member of a type a particular accessibility level. Accessibility levels are used in C# to disallow certain areas of code from accessing your own code that you define and you give an access level to.
Wow, that was a very nice description, Nelson. Well, it was. All right, let's go ahead and jump into some quick examples.
Okay, so basically, when we have a class or an interface or a enumeration or a delegate, we can give them two types of access modifiers or two levels of accessibility. There, of course, though, is the default accessibility. And this is an example of a class without any access modifiers attached to it. And as a result, it has a default accessibility of internal. You can also specify that accessibility explicitly by adding the internal modifier to the class definition. So the internal modifier, or if all accessibility was omitted and it defaulted to internal, what that means is that this class, both person and in this case program, can only be accessed inside of this assembly that we're working on. If we were to create another assembly and reference this assembly, then we would not be able to access person or program in any static way. And what I mean by any static way is that it doesn't mean that person or program, those classes disappear or are magically erased. They're still there. If I were to have a method, a publicly accessible method in this assembly that returned a person object, but it was cast to an object type or an interface type that also happens to be public, that object would still be valid in another assembly. Also, if I were to use reflection to get access to the person class and invoke his constructor, I would then be able to create a person class outside of the assembly, even though he's internal. Internal is just a way, accessibility modifiers in general are really just a way to limit what you can statically access in C# code.
Okay.
So the other type of accessibility we can add to top-level types, and a top-level type is, for example, the person or program classes, which are not nested in any other type, is public. And public is a modifier that gives this class public accessibility, which means that there are no limitations as to the accessibility of this type. If you can import this namespace, if you can reference this assembly, you can access person statically. So remember, public and internal are the default for, or are the only accessibility modifiers we can add on top-level types. However, there are a few different rules because enumerations, for example, have a default of a public accessibility, as do interfaces. So by default, these guys are both public, whereas if I were to take off this public access modifier, class would be private. So as far as member accessibility, in structures, class, and classes, you can define your own members with accessibility levels. In interfaces, you can define your own members, but you can't give them accessibility modifiers. Everything inside of an interface is considered public. Now, inside of a class or a structure, we have a few different accessibility modifiers we can add to members. So I'm going to go ahead and write a few different methods showcasing the different types of accessibility modifiers. But remember, these accessibility modifiers are available and behave the same way on methods, fields, events, indexers, and nested types, such as a nested interface or a nested class. So I can go ahead and write public void test, private void test 2 to get rid of the name conflict, protected void test 3, internal void test 4, and protected internal void test 5. So these are members of this class, and they all showcase a different accessibility level. However, I do want to point out, though, that because this class is an internal class, he can still only be accessed through through another type inside of this assembly. He still can't be accessed if this test method were to be public. it still would be inaccessible from other assemblies because the enclosing type is internal. But yes, so public members behave in the exact same way as I described public classes. They have no restrictions as to where they can be accessed. Private members, which is, by the way, the default accessibility for all members inside of a class. So if I were to omit the accessibility modifier, this test2 method would still be private. And again, this is true for all members that we may make inside of this class. But the private modifier makes it so this accessibility of this test2 method is only accessible from within this class. You can only statically access test2 from code within the person class. Protected means that you can only access this method, or this member rather, from inside of the class it's defined in addition to the classes that inherit from this class. So if I were to have
we can actually just give a real quick example as well.
Yeah, if I were to create another in-person
let's say a more concrete person, so like an employee, yeah.
And I were to give him a method, the accessibility of this method is irrelevant, by the way. We can see that if we do this dot, we get access to test because it's public. We also don't get access to test2, but we also get access to test3, and because it's protected. If I were to have an a person object instantiated elsewhere, like down here, you'll see that, again, we only have access to test, which is public, but we do not have access to test2 or test3. So inside of, so that's protected. Internal is very similar to an internal type or an internal top-level type. It's only accessible from within this assembly. It's not statically accessible from any other assembly that might reference this assembly.
Meaning it basically acts as if it's public within this assembly, but external in another assembly, it simply cannot be seen.
Right. Protected internal does something similar to protected and internal, in that it can only be accessed by child classes that are inside of this assembly. So as far as the different accessibility modifiers, this is about it. But I do want to point out something interesting. If we were to have a nested type inside of this person class, nested type inside here, and then give him test7, if he were to receive a person reference, he can actually access everything. He can access the private, the protected, the internal, and the protected internal. So this is a kind of neat little trick about how accessibility modifiers work, in that your nested classes can access the private members of the encasing type. But other than that, that really wraps up our discussion on access modifiers. We covered all the different ones, where they're used, and what the defaults are if you don't provide them.
Awesome. And with that, we'll go ahead and conclude this video. Thanks a lot, everyone.